Question number 41. Consider a schema relation is given, and for those relation A, B, C, D, E, F are the attributes and the functional dependency is given. What is the number of super keys? So you will have to count the total number of super keys. So this super key is a set of candidate key, or we can say the minimum key that will determine all of the attributes, right? So let's first find out what is the candidate key for the given relation. So if you look at the dependencies here, then A determines B, C determines D, and E determines F. So let's so what what set or closure of set will determine all of these things. So that A, B, C, D, E, and F. So if you look at the functional dependencies, then here you see that B and D, so these are already determined by according to functional dependencies. These B, C, B, D, and F is already getting determined by some other attribute, right? So these cannot be in the set of minimal key, right? So what could be? A can be there, and C can be there, and E can be there. So A, C, E. So this will determine your complete set of attributes, right? If you take the closure of this A, C, E, then if you look at this, then A, C will be there in this set. Also A determines B, so B will be there, and C determines D, so D will be there, and E determines F, so F will be there. So by getting this key, we are able to determine all of the attributes. So this is the minimal key that we can take as the candidate key. So we have the candidate key, so this key is determining the other attributes, right? The other attributes are B, D, and F. Now what is the question is asking number of super keys. So what will be the number of super keys? So this is the candidate key only. So using this, so what we can do, we can anyhow we will have to take this key, right? With this we can take B, D, F, any of one, or any of two, or maybe and all three. So we have 1, 2, 3, 4 elements in a set. Then what are the total possible that we can form? Like we can take this one ACE single, then we can take with with ACE we can take B, we can take D, we can take F. So again with ACE we will have to keep this, and we have how many elements remaining? 3. So number of possible that subset that we will form is 2 to the power 3, right? Because we are keeping this and we have the 3 choices, so it will be 8. So total super key will be 8. So the correct answer for this is 8.